Usually when we look at a spreadsheet, there's this illusion of perfect order.
Oh, totally. You see those neat rows and columns, and it just feels like you're looking at absolute truth.
Right. But step behind the scenes of data analytics, and that perfect grid is, well, it's full of invisible tripwires.
Yeah, it really is. It can be a total minefield.
So today we're jumping straight into an exploration into our source material. We've got a deep dive recording of a data analytics masterclass focusing specifically on Excel and Power BI.
And the mission here is to really decode the unglamorous magic of data cleaning and eventually the ultimate payoff of pivot tables.
Exactly, because for a curious learner like you listening right now, staring at raw data trying to find those aha moments can feel pretty overwhelming. You first have to survive the traps.
Oh, absolutely.
So by the end of this exploration, you'll know how to spot the stealthy saboteurs lurking in your data sets like those invisible spaces. And we'll also get into the golden rule of pie charts that saves literally everyone from visual disaster.
I love that rule. But before anyone can extract those brilliant business insights, you really have to face the messy reality of raw information. Specifically, the gaping holes where data should be.
Right, the null values.
Yeah, null values. Our source starts by distinguishing categorical data, text labeled ABC from numerical data labeled a 1, 2, E3 for whole numbers, or maybe 1.2 for decimals.
And handling those empty cells in your columns brings us to techniques like forward fill and backward fill.
Right, which essentially means using the preceding or subsequent value to just fill in the blank spaces.
Okay, let's unpack this for a second. It's almost like a bricklayer smoothing mortar, right?
Yeah.
You can only drag the mortar forward if you are absolutely certain the row underneath follows the exact same pattern.
What's fascinating here is that filling data isn't about guessing at all. It's a systematic application of consistency across the board.
So you're using the exact same method for 10 records as you would for 1,000.
Exactly. You have to identify a guaranteed cyclical pattern first. It's much like a secondary school math sequence where you consistently add free, like 2, 5, 8.
But wait, let me push back on that. If we are just copying and pasting previous dates to fill the blanks using forward fill, doesn't that run a massive risk of artificially skewing the data set if the pattern gets broken?
Oh, you hit the nail on the head. You cannot use forward fill just to make a spreadsheet look complete.
Right, because that's just making things up.
Exactly. If that pattern isn't undeniable, you are basically fabricating history.
Which brings us to the most infuriating saboteur in a spreadsheet. Because sometimes missing data isn't even the problem. Sometimes the data is there, but it's wearing a disguise.
Yeah, inconsistent text formatting is a huge one, like having two versions of London, one with a capital O and one with a lowercase l, or New York versus New York.
To the human eye, it's the exact same place.
Right, but to a data engine, they are entirely different entities. So you fix this by applying data validation to just capitalize each word consistently.
Here's where it gets really interesting, though. The trailing white spaces.
Oh, those are the absolute worst.
Right. A trailing white space is basically an invisible tripwire.
Yeah.
You hit the space bar in a Word doc, and absolutely nothing happens.
Yeah.
But you accidentally hit it in an Excel sheet, and suddenly your entire pivot table thinks London space and London are two totally different cities.
Which is exactly why the trim function is so essential. It is used specifically to strip those hidden characters away.
Yeah, and the source also talks about dealing with completely blank city fields. It insists on replacing them with the word unknown rather than trying to guess.
If we connect this to the bigger picture, data integrity is really about removing assumptions. Trimming spaces and using unknown ensures the analysis remains completely objective.
Because guessing would just introduce analytical bias toward a specific city.
Exactly.
So the text entries are clean, but then we hit what might be the most notoriously frustrating data type of all, time.
Ugh, dates. They're so tricky. The source explains why dates currently formatted as text, or ABC, must be converted into the actual date format.
Right, because if they stay as text, you're severely limited.
Exactly. In Power BI, formatting a column properly as a date unlocks the date hierarchy. That actually allows the user to dynamically drill down from years to quarters to months and days.
And text formats simply cannot do this.
No, they can't. But transforming text into dates can trigger absolute chaos.
Oh yeah, there's a wild case in our material where converting text to dates resulted in a massive 61% error rate.
Yeah, that happens simply because of mixed source formats, like day, month, year clashing with month, day, year in the raw data.
So what does this all mean? If you just click remove errors, you lose 61% of your sales records.
This raises a really important question about data preservation. It is always better to creatively salvage records, like finding the mode, which is the most frequent date, say March 31st, 2020, to replace the error gaps.
Or in basic Excel, temporarily leaving it as text.
Right.
But wait, let me play devil's advocate here. If converting text to dates breaks 61% of the sheet, why can't we just leave it as text permanently if we only want a quick glance at the sales?
Wow.
Like, is the drill down feature really worth the headache of re-imputing all those errors?
It's a brutal trade-off. The argument for using the mode is strictly to salvage the underlying sales revenue figures when the total dollar amount matters more than the timeline.
Oh, I see.
But if you artificially cram over half your sales into March 31st, your quarterly trend insights are totally ruined.
So it forces you to ask what question actually matters most to your analysis before you start cleaning.
Exactly. And assuming we've navigated that minefield, all that meticulous trimming, filling, and formatting was simply the groundwork.
Right. The ultimate payoff is actually making that data speak using a pivot table.
Yeah, the material defines a pivot table as an interactive summarization tool. It's used to aggregate, calculate, slice, and reorganize large data sets without ever modifying the source data.
So a pivot table isn't creating any new data whatsoever. It's basically just putting a highly organized mathematical magnifying glass over what we already have.
That's a perfect way to put it. The value of a pivot table is that it is a sandbox. It protects the original data while allowing infinite exploration.
But the key is defining the insights before building it, right? Like finding the city with the most sales or the overall sales trend.
Yes, and that requires bivariate analysis, which just means comparing two columns, like putting city on the row and sales on the values.
And it requires mandatory aggregation, too.
Right. You can't just find the top city without first telling the system to use a function like sum, max, min, or count to combine all its individual sales.
And the material notes you can also filter by value to extract highly specific data points, like the top 7 sales by date.
Which brings us to the visual side of things. A pivot table is perfect for the data analyst, but to present these findings to stakeholders, you have to translate those aggregated numbers into a visual language.
Enter the pivot chart. It's the direct, dynamically linked visual counterpart to a pivot table. So if the table updates, the chart updates automatically.
Exactly. And there are strict rules of visualization here. For example, a pie chart should only be used if the categorical data, the legend has 4 or fewer items, like showing percentage proportions of a total.
I absolutely love that rule of 4 because, let's be honest, a pie chart with 12 different slices isn't a chart anymore. It's just a blurry dartboard.
Yeah, it really is. If there are more than 4, it just becomes clumsy, and a column or bar chart must be used instead.
What's fascinating here is the absolute focus on user experience. A chart shouldn't just be accurate. It must be immediately readable without requiring the viewer to squint.
There are some great formatting tricks for this in the material, too. Keeping charts clean by adding data labels, but only to the tallest bar to avoid visual congestion.
Oh, that makes so much sense.
Yeah. And removing background grid lines, smoothing out the peaks of a line chart, and rotating the x-axis text 45 degrees so dates don't squish together.
It's the little things that transform chaos into clarity. I mean, we started deep in the mud with invisible spaces and broken dates and ended with dynamic, beautifully formatted visual insights that actually respect the viewer's time.
It's a huge journey from raw data to a clean dashboard.
For you listening, whether you're prepping for a major presentation or just trying to organize your own personal projects, the integrity of your foundational data dictates the quality of your final decisions.
Which really leaves us with a provocative final thought. A sort of data analytics ship of Theseus.
Ooh, I like where this is going.
If the tools we use to clean data, like replacing missing dates with a statistically frequent mode, or labeling blanks as unknown, inherently rely on human choices and algorithms, at what point does clean data stop reflecting objective ground truth reality and start reflecting our own structural biases?
Wow. Definitely something to ponder the next time you look at a perfectly neat spreadsheet and assume it's the absolute truth.